In the name of Allah, the most gracious, the most merciful, I will talk about communication schemes. First, we will discuss overreach and underreach. Let's talk about 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 overreach and underreach. The voltage within your line can be inside your line or outside, functioning as a layer, right? Zone 3, Zone 4, Zone 5, it's all the same, no? So of course, when something comes to Zone 2, for example, if the voltage is within my line, I will treat it like the voltage outside my line so that it is considered after a time delay, right? This is similar to overcurrent. Overcurrent, as soon as it sees voltage, wherever it is, as long as the voltage current is usually its sphere, it is considered. This is what we call non-unit protection. Unit protection means something like differential protection, like busbar differential, and like transformer differential, which is something that protects a specific area and can quickly respond to voltage within your zone. Hello to you all, hello to you all, hello to you all. To convert distance from ununit to unit, use the distance communication scheme. Overreach, underreach, unblocking, and blocking. Why? Because if a fault occurs on my line, I want to perform a trip operation. He says, well, if the fault is within my line, I want to speed up the tripping process. This communication scheme interacts with our line, speeds up the process, and ensures the fault is internal. Is this good? So it was said that we will do something like this, meaning the relays must communicate with each other because each one tells them that it saw the fault in any zone. Meaning if one saw it in zone 1 and the other in zone 1, then there is a fault between them. This one saw it in zone 1. And this one sees it in zone 2. So surely the fault is between them. Why? Because zone 2 obviously starts seeing from after the 80%, and for the other, it's zone 1, so definitely there is a fault. Thus, they must exchange this information in the form of a carrier signal. Great, excellent. So what did he say about the problems he encountered, or what happened with him initially? He said that the communication between the two relays, when they talk to each other, occurs when zone 1 is triggered. Meaning, if this one sees a zone pickup, or that one sees a zone pickup, it sends to the other saying, be careful, I saw the fault within my line. Okay, great. What happened with the short lines? If a critical fault occurs in the section between the two lines at say 50% of the line, and this fault causes an arc or a fault due to poor impedance. Is that clear? At that time, the value of the arc resistance becomes significant relative to the impedance under the line itself. Consequently, it might make it 50% plus, and this could give it an additional 30% or 40%, so it sees it as zone 2. And the same applies to the other side. In this case, the voltage is within them, but both do not see each other because this sends them information saying, I saw zones. So the information between them will not be sent now. Both will synchronize despite the voltage being within their line. However, in long lines, the stopping impedance on the line is much greater than its values and this voltage impedance. And that's it. So what happens is that even if it occurs in the critical area between them, if you add 10% or 20% more, they won't go outside. For example, even if the fort was 60% or 70% away from this breaker will be seen at about 90%, for instance. But the next breaker is still seen where? Inside one zone. Therefore, in the underreach, the understanding between the two leaders is achieved through one zone. But in the understanding between the relays, it is done through zone 2, which is the adjustment we made to be used with short lines. So, the information exchange between the relays is exchanged with zone 2, which is originally the understanding of zone 1. Is that clear? Because you need to find someone to say zone 2, understanding zone 1. The translator for the channel, So it depends on pickup zone 1, it depends on pickup zone 2, and it depends on pickup zone 3, right, man? Of course, or zone 4 you mean, not just underreach, now in short lines, the underreach in long lines.
But in the short lines, we stay with zone Topeka, right? We stay in the short lines, 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 we stay in the short lines.
Then we do, they did, we do. And the underreach with long reductions, and the underreach with long reductions. For example, the lines I found are approximately 380 kilovolts, and their connection is approximately. The distance is just level 100 kilometers. Long lines and medium lines. We take in the college long lines, we take long lines and medium lines. Didn't we used to do this in college? We said something like 50 miles and something like 90 miles and 400 meters. Yes, we took it in college, long lines from that. Weren't we making the connection for buses? Weren't we modeling the long, short, and medium lines? We were doing that. We used to shape the pie and the long lines.
I don't know how we did it.
So we used to take distances of struggle for the long, short, and medium lines. How? After that, there is zone 2 pickup in the overreach, zone 2 pickup in the overreach, zone 2 pickup in the underreach, 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 zone 2 pickup in the Kariri and Zokariri. In this case, don't tell me whether the communication is correct or not. Why? Because if the communication is incorrect, its saturation doesn't matter to some extent. The safe thing is to trigger a phase skip. What is a phase skip? Zone 2 trip. Correct. But I don't trigger an edit. Right? Yes? Because we will see the opposite of this statement. We will see this statement. We will see that there is a different statement in phase skip. Let's look at phase skip. What is phase skip? The blocking scheme tells you first that I will deal between the relays where the relay provides information to another, not that the internal voltage gives information. Internal voltage means in overreach and underreach. It's called permissive overreach and permissive underreach, or permissive overreach transfer trip, or permissive underreach transfer trip. Permissive means if I give you a carrier send, I give you permission to trip with aid. Correct. Transfer. Trip permissive means that when I give you my carrier send, I am giving you permission to trip with aid. Correct. Is that correct? In a blocking scheme, what happens? The breaker, for example, like the one we are focusing on, if it detects a reverse voltage, it sends a blocking signal. As the name suggests, it sends a block signal, meaning the carrier send that goes from this breaker to that breaker is called a block. Why? Because the information it sent is that the voltage is reversed, indicating that I see this voltage as reversed, okay? It tells you that this voltage does not have a reverse, so you are not supposed to request it, and your carrier send follows with the reverse zone pickup. Okay, that's good. Secondly, if you see zone 2, meaning the voltage is zone 2 plus carrier, send, it requests a basic skip, okay? To ensure that when this breaker requests, okay, if you see zone 2 pickup, and it provides the carrier receive, which is supposed to trigger the receive, but this is not correct. Why? Because I have not ensured whether the communication is sound or not. The communication cannot be incorrect between the two sides, meaning I will not know what? I will not engage the carrier receive in this case if the communication is incorrect. Incorrect. If it is incorrect, I will not trigger the receive. But if there is a receiver in the future, there will not be a receiver in the future unless there is a receiver in the future. The communication must be correct, or there will not be a receiver in the future. What does that mean? Where is this part? Exactly. This is the part where it is in the... Look now. It must cover the distance higher or greater. Supposedly, from the first bracket, it will cover its zone. For example, a specific distance, for example. Nice, all nice. It must then cover a smaller and greater distance. We must cover the second line, from the second line. Look, let me tell you something. Let's say this covers up to here, but yes, This is what will make it cover how much of the second line. And this curve covers from the second line. Ah! If the zoom is here, it covers a distance from this line. Less than the distance covered by the breaker. This is another board, so I see what I should skip. Reverse, but I don't see reverse. And this sees zone 2, so it will see zone 2 pickup, and as Carl Russell and the communication are seen like this, so it sees Carl Russell and the communication like this, so it sees Carl Russell and the communication like this, so it sees Carl Russell and the communication like this, so it sees Carl Russell and the communication like this, so it sees Carl Russell and the communication like this, so it sees Carl Russell and the communication like this, so it sees Carl Russell and the communication like this. Thank you.